Hello everyone, welcome to Organic Chemistry lecture. Our topic name is Application of Electronic Effect. These are the learning outcomes, and today we are going to understand about the application of the effects we have studied. So for now we have studied the three permanent effects, that is mesomeric, hyperconjugative and inductive effect. So out of these three, the mesomeric effect is the dominant one than the other two. So firstly comes in the dominance order, firstly comes the mesomeric, then hyperconjugative and then the inductive effect. But in an exception, when a halogen is attached to a conjugated system is like example is benzene. So if a benzene ring is connected to a halogen, say chlorine, bromine or iodine, then in that case the minus inductive effect will be dominant than mesomeric effect. So this is some exception. Now these electronic effects have a various large impact on the properties of organic molecules or species. So let's understand these effects application. So first of all we will talk about the effect on stability of carbon intermediates. So in order to understand this thing, the stability of carbon intermediates, you should keep in mind that whenever the charge will be more delocalized, there will be greater stability. That means the more is the delocalization of the charge, greater will be the stability, as it happens in resonance also. So suppose we have a carbocation or a free radical. These kind of species are electron deficient. So to make them stable, we need a electron donating group like plus I, plus M and plus H group. These are plus inductive effect, plus mesomeric effect and plus hyperconjugative effect. So whenever these kind of electron donating groups are attached to these electron deficient group, they get stabilized. But if we have species like Carbanions which are rich in electrons, then we need some kind of group which can take back the electron, means we need electron withdrawing group, and these are minus I and minus M effect. So this is how we make the carbocation and carbanions stable. So in general, these carbocations are unstable. Why? Because of the electron deficiency on the carbon atom which is positively charged. And to make that species stable, we need some groups which can donate the electrons to it. So here I have shown you the order of relative stability of these carbocations. So you can clearly see that the carbon which is attached with 3 methyl group, means the electron donating group, it have highest stability. Why? Because these electron donating groups are giving it electron, so it's becoming stable. Okay, so we can say that the 3-degree carbocation is more stable, then comes the 2-degree one, and then the 1-degree one. So this is the order of stability. However, the carbocations like allyl and benzyl, they are stable due to resonance, because resonance can happen there. Here I have shown you a picture showing the allyl carbocation and benzyl carbocation. These have slightly greater stability than the secondary carbocation, but they are less stable than the tertiary carbocation. And tertiary carbocations are such as phenyl and CS2 double bond CH groups. These are not good electron donating group, as it is evident from the fact that C6H5COOH and CH2CHCOOH, these are stronger acid than acetic acid. That's why they are not good electron donating group. So whenever there will be a question, you have 2-degree carbocation, allyl carbocation and a 3-degree carbocation, then the stability order will be 3-degree carbocation, then allyl one, and then the 2-degree carbocation. Okay, Now the substituted allyl and the substituted benzyl carbocation have greater stability than the tertiary carbocation. Okay, this is a case of substituted one. Why? Because of both resonance and the inductive effect. They have inductive effect also and resonance also. That's why they are more stable than 3-degree carbocation. So these things you have to keep it in mind. Vinyl carbocation on the other hands are less stable. This is thus the overall stability of the carbocations are in this order. First of all comes the substituted allyl or benzyl, then comes the 3-degree, then comes the 2-degree or the allyl or benzyl which are not substituted, and then 1-degree, and at last the vinyl carbocation. Now let's talk about the stability of Carbanions. The Carbanions are unstable due to negative charge on carbon, and any factor which increases this negative charge makes them more unstable. So what we need to make them stable? We need some groups which can take back those extra electron. So for that we need minus I and minus M effect. So here you can see in this order the 3-degree Carbanion is less stable than the 1-degree one. So the Carbanion stability order is just opposite of stability order of carbocations, and this is why due to the destabilizing plus I effect of alkyl group. Here the allyl and benzyl carbanion are as usual more stable due to resonance. Okay, this is the same reason for stability of allyl and benzyl carbanion as it was for carbocation. Because of resonance they are more stable. Now the carbanions which is attached with a halogen are more stable than the simple one. Why? Because the halogen is a electron withdrawing group, and here in this case Cl minus Cl bonded with CH2, here Cl is withdrawing the extra negative charge from carbon. That's why this ClCH2 is more stable than the CH3 with a negative charge. Okay. Now let's talk about the stability of carbon free radical. The free radicals are unstable due to unpaired electron and electron deficiency at the carbon atom, and electron donating effect increases their stability. So our free radicals become unstable if they have unpaired electron, or say they have lack of electron. Then some electron donating effect like this was the case in carbocation also, they can increase their stability. Here the stability order is same as it was for carbocation, 3-degree, then 2-degree, then 1-degree. So this is due to increase in the number of plus I effect of the alkyl group. However, carbon free radical like allyl and benzyl are stable due to resonance, the same case. Thus, allyl and benzyl carbocation have greater stability than tertiary, secondary and primary free radicals. Thus, the overall stability is in this order. First of all comes the allyl or benzyl group, then comes the 3-degree, and then 2-degree, and at last the 1-degree. So here in this lecture we have studied the electronic effects on carbocation, carbanion and free radical. Let me ask some objective question related to this topic. Here the first question is, when chlorine attached to conjugated system like benzene, which electronic effect will be more dominant? So as I have told you, that is negative inductive effect, and in general it is mesomeric effect. In second question, here you have to choose the correct stability order of the following molecular species. So in this case, first order is the correct one because all these are carbocations. So here we have, in this lecture we have covered all these topics.